Welcome back to my lesson, my video lessons. Last week we started with statistics and I was able to explain measures of central tendency. We saw the formula how to calculate the mean, median, and mode of small sample. That is, the data set that is less than 30. And I gave some assignments and exercises, and I believe you've all attempted the questions, but I'm yet to receive the solutions from every one of you. Endeavor to do that today before the end of this class. I want you to post in your solved exercises and assignments, just like the way I've explained to you earlier today. It's going to be private, no public posting anymore from now henceforth. Please follow the procedure I explained earlier before this video. All right, so today my focus is going to be on meaning and computation of mode of ungrouped data. Meaning and computation of mode of ungrouped. All right, so the mode of a given data is the item which occurs most often in the distribution. Example 1, the record of the marks scored by a number of students in an oral test in economics is as follows: 10, 10, 5, 9, 15, 10, 20, 10, 9, 5, 9, 10, 25, 9, 5, 25. Find the modal mark. Like we said, the mode is the data or the data that occurred most. So to answer this question, let us make use of the help of a table. So here is the table below. I have formed the table of 2 rows, okay, and 7 columns. So the row title here is the marks, while this is the frequency. So you see there are 3 people who got 5 marks, 4 got 9, 5, 10, 1, 15, 1, 20, and 2, 25. So since we define the mode as the data which occurred most, or the data with the highest frequency, so it is obvious that the modal class is the modal mark, is 10. Why? Because 10 occurred 5 times. There are 5 students who scored 10. Okay. Example 2. It says for a class of 30 students, the scores on a math test out of 20 marks were as follows. So here are the scores of the math test for 30 students. All right, so it's expected that we should find the modal class. Now to solve for the modal class, same thing, using the table will help us visualize the data easily. You can also get the modal class from the given data set, but it's going to be at times stressful or difficult to do that. So that is why it's always good to translate into a table. So here are the marks and here are the frequencies. By inspection, max 14 is the one with the highest frequency. Therefore, 14 is the modal score. Is that taken? All right. Now, here is some class activities for you guys. Please attempt these questions and post it before the end of this lesson. So you are expected to pause this video at this point and solve, then post. So activities, find the mode of the following distributions. Ages 13 to 18. Frequencies are given as follows. Now the question that follows this table is this: which of the following is not a measure of central tendency? The mode, the range, the mean, or the median? First, understand the question. First, find the mode of the distribution given in the table. Then, which of the following is not a measure of central tendency? Then question 2. The table shows the distribution of test scores in a class. If the mean score of the test is 6, find the values of K and the median score. So here is the distribution again. To solve for the values of K, we said values. Why? Because this is a quadratic expression. So it's expected that there are 2 values two possible values of k. All right. Okay. All right. So we are going to now talk about measures of location or dispersion. Sorry, measures of dispersion. All right. So the measure of dispersion, also known as measures of variation, is concerned with the degree of spread of the numerical value of a distribution. Now recall that I mentioned in my previous class that the measures of location or measures of central tendency tries to get the mean data of any given data set. The center is trying to centralize the data. But these measures of dispersion tries to calculate or estimate the, the rate at which each data sets are far away from the middle. So the spread, how widely spread is this given data set? That is what the measures of dispersion or variation tries to calculate. So there are a good number of measures of dispersion. Just like we have measures of location, we have the mean, median, and mode for measures of location. For measures of dispersion, we also have a good number of them. So I will start discussing those measures of dispersion, starting with the range. So say range, this is the difference between the maximum and minimum values in the data. Example 1, find the range of the data 6, 6, 7, 9, 11, 13, 16, 21, and 32. Solution, the maximum data in this set is 32 and the minimum is 6. Therefore, the range is 32 minus 6, which is 26. Okay, example 2. Find the range of the distributions below 65, 62, 62, 61, 61, 60, 60, 59, 58, 52. The range is given by this, 65 minus 52. Why? Because 65 is the maximum data in the data set, while 52 is the minimum. So the range is given as 13. Very, very simple. So you can see it's straightforward. Very simple. All right, so very easy to calculate range. So don't forget a range, or range is an example of a measure of dispersion. 2, let's quickly look at the deviation from the mean. Deviation from the mean. If the mean of a distribution is subtracted from any value in the distribution, the result is called the deviation of the value from the mean. Consider the table given below, which is the set of examination marks. 65, 62, 62, 61, 61, 60, 60, 59, 58, and 52, the previous data set we considered earlier. Now let's calculate the mean of this data. The mean is given by 60. When you add up all the numbers, divide by 10, because there are 10 data in this 10 datum in the data set. So the mean is 60. The deviation from the mean is given by this. Here is the formula to calculate deviation from the mean. All right, so 65 minus 60, which is plus 5, 62 minus 60 plus 2, 62 minus 60. We subtract 60 from each of the data points in the data set. And the deviations of the scores from the mean are given as follows. So if you observe, you see that the sum of these deviations is equal to 0. Class activity 1. Calculate the range of the following distributions. A, 72, 78, 72, 90, 72, 83, 79. B, 3.9, 4.0, 4.2, 3.9, 3.8, 4.0. Question 2. Calculate the mean deviation of A1 of 1A above and 1B. Please pause this video, attempt these questions, post the answers privately. I'll provide areas where you post different answers to each problem or activities. Definition and calculation of variance. The variance is the arithmetic mean of the squares of the deviation of the object observations from the true mean. It is also called the mean squared deviation. The formula for variance for a small or group data is given as summation x minus x bar all squared over n. This is for an ordinary distribution, that is an ungrouped distribution. While we have summation f of x minus x bar all squared over summation f for a frequency distribution. So any distribution with frequency, this formula is valid to calculating the variance, while an ungrouped data this formula is valid for it. Let's look at some examples on how to calculate the variance of a given data set. Calculate the variance of the following. Example 1. Calculate the variance of the following distributions of the ages of 50 pupils in a school or in a secondary school. Ages are given as the first row of the table, while number of pupils is the second row. Solution. Now you see that the tables that were formed to calculate the mean, median, and mode of measures of central tendency is quite different from the table you'll be seeing right now, because here we're going to be adding more columns for us to be able to calculate the variance. We will form this table by adding all the ages, 10 to 16, the frequencies of each of this age, or each of the age, and next we need fx. So the columns that are required in the table depends on the formula that you want to use to calculate whatever statistic. Am I making sense? So in the formula we require, we need f of x minus x bar. We also need f, or summation f. Don't forget that x bar is the mean of the data set. So, and from the formula of the mean, summation f of x over summation f, we also need f of x. That is why we take the product of the ages by the frequencies. So this 10 times 18, 180, 12 times 4, 48, 13 times 6, 78, this times this, 40 times 12, 168, 15 times 6, 90, 16 times 4, 68. Then you also need to solve for the absolute value of the deviation. The absolute, we don't need a positive, we don't need a negative result. So we take the absolute of the deviation of each point from the mean. All right. So, but before doing that, we have to calculate the mean first, and the mean is given by summation f of x over summation f. When you compute the mean, we got the mean as 12.6. So when you take the deviation of each point from the mean, 10 minus 12.6 is 2.6. That is the absolute value of that result. Okay. So how do we get 0.6? 12, the age 12 minus 12.6, we give negative 0.6. But when you take the absolute value, that will give 0.6. The absolute value is just a positive value. The positive value. All right, let me explain again this absolute, what absolute means. The absolute value of any number is a positive value of that number. The absolute value of 3 is 3. All right. The absolute value of negative 3 is positive 3. Okay. So when you take the absolute value of any number, you get the positive of that same number. So that is what is happening here. All right, so don't forget the mean x bar is, we've gotten the mean x bar below as 12.6. All right, so and we're taking the difference. So now 13 minus 12.6 is 0.4. 14 minus 12.6 is 1.4. 15 minus 12.6 is 2.4. 16 minus 12.6 is 3.4. Then we squared the absolute deviation. So 2.6 squared is 6.76. 0.6 squared is 0.36. 0.4 squared is 0.16. 1.4 squared is 1.96. 2.4 squared is 5.76. And 3.4 squared is 11.56. Then we take the product of the frequencies and the squared of the absolute deviation. 18 times 6.76 is 121.68, or 68 rather. 4 times 0.36 is 1.44. 6 times 0.16 is 0.96. 12 times 1.96 is 23.52. 6 times 5.76 is 34.56. 4 times 11.56 is 46.24. Then take the summation of all of these, add this. 221.68 plus 1.44 plus 0.96 plus 23.52 plus 34.56 plus 46.24, that will give 228.4. Okay, we've done this earlier to get the mean of the data. And now we can go ahead and apply the formula. So the variance is equal to summation f of x bar all squared over f of summation f. And that is equal to 228.4 0.4 over 50, 228.4 over 50, and that will be 4.568, which is approximately 4.6 approximately. So this value means that the spread of each data set from the mean is by 4.6 approximately. I hope you understand that explanation. Please, if you don't, try and watch this section again and again and put it into practice. All right, practicalize it by solving yourself. I believe you get a full understanding. Now, but let me take the second example. Calculate the variance of the distribution below. We have 90, 80, 72, 68, 64, 56, 52, 48, 36, and 34. All right. Solution. The mean x bar is equal to summation x over n. So because here our n is small, it's a small sample. So when we sum all of this divided by n, what's our n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 90 plus 80 plus 72 plus 68 plus 64 plus 56 plus 52 plus 48 plus 36 plus 34 divided by 10 will give 60. All right, that is the mean. Now let's proceed. So we write down all the distribution of data points, data sets down on the table, the first column, that's our x. Then we'll find the deviation, subtract the mean from each of the data points, and that will give this, the squared deviation. Then take the sum of the squared deviation, that will give 3,000. Therefore, the variance is equal to 3,000 over 10, and that is 300. All right, so this is for a small data set. All right, so here is for another class activity. Calculate the mean and variance of the ages of 12 students aged 16, 17, 18, 16.5, 17, 18, 19, 17, 17, 18, 17.5, and 16. Pause, solve, and submit privately. All right, next. We're looking at definition and calculation of standard deviation. So standard deviation is the square root of variance. Very simple. If you can calculate the variance successfully, then take the square root of the variance. That will give you the standard deviation. Very, very easy. Okay. So here is the standard deviation. The first formula A is formula to calculate standard deviation of a small data set. While here is calculate standard deviation of data set with frequencies, all right, or grouped data set. Example 1. Find the variance and standard deviation of the sets of numbers 2, 5, 6, 3, and 4. All right, we need the mean. Calculate the mean. 2 plus 5 plus 6 plus 3 plus 4 divided by 5, and that will give 4. All right, that's the mean. We've gotten our x bar, mean x bar. Now let's go ahead and put this on a table. So each of our data sets, 2, 5, 6, 7, 3, 4, and the deviation from the mean, minus 2, 1, 2, 1, minus 1, 0. Then the square of the deviation is the third column. Then take the sum of the square of the deviation, that is 10. Now go ahead and solve for the variance, 10 over 5, which is 2. Then the standard deviation is square root of 2, which is equal to 1.414. All right, very, very simple. Example 2. Calculate the standard deviation of the distribution. The table is given below, and let's go ahead and solve. So first we need to calculate, so this is reference to example 2 in pages 3 and 4. First we have to calculate the what? The standard deviation, the mean of the data, or the group's data set. Or we've already done that from example 3 and 4. We've seen the standard deviation as 228.4 over 50. And when we take the square root of that variance, we get the standard deviation. Straightforward, very, very simple. So now I want to quickly talk about grouped data. So this is a kind of data presentation where values are grouped into different classes called class intervals. Now let the record below be the mass of some people in kilogram. So you're given the mass of people in kilogram. Now, should bar charts be drawn for the different masses above, there would be too many bars. So the data may be grouped into class intervals and then frequency distribution table prepared. Appropriate class intervals are 21 to 30, 31 to 40, 41 to 50, and so on and so forth. So each data belongs to one of the class intervals. Each data is first represented by a stroke in a tally column. Every fifth stroke is used to cross the first four counted. The number of tally in each class interval gives the frequency. So if I'm to represent this in a frequency distribution table, this data set, it will give birth to this table. All right, so here are the frequencies, here are the tallies, and here are the class interval. We use the class interval 21 to 30, 31 to 40, 41 to 50, 51 to 60, and all up to 100. So the modal class is the one with the highest frequency. So where is the modal class? This class, the class with frequency 11, 61 to 70. So it means there are many people with masses between 61 to 70, or there are the highest number of people between 61 to highest number of people with masses 61 to 70 are those part of the data set. All right, so here are other class activity. Prepare a frequency table using class intervals 1 to 20, 21 to 40 for this course by 30 students. So here's the table. Prepare the frequency distribution table. Number 2, the class marks scored by 50 students in an examination paper are given below. Prepare a frequency table using the class interval 10 to 19, 20 to 29, 30 to 39, etc. Now also solve for the class, the modal class. Okay, so calculation of class boundaries, class interval, and class mark. Grouped data can be represented using a kind of rectangles called histogram. The width of the rectangles is determined by the class interval while the height is proportional to the frequency in that interval. To close up the groups between the class intervals are both ends, at both ends to have a common boundary in between two intervals. From the last frequency table above, we get this table. So here we computed the class boundaries from the class intervals. So you see what's happening? Subtracted 0.5 from 21 and added to 30. 21 minus 0.5 is 20.5, added to 30, that's 30.5. 31 minus 0.5 is 30.5, added to 40, 40.5. 41 minus 0.5, 40.5, add 0.5 to 50, 50.5. You keep doing that until you get to the last class interval. So that is how to get class boundaries from class interval. This is the lower class limit, the upper class limit. Subtract 0.5 from the lower class limit and add it to the upper class limit to get the class boundaries for each class intervals. I hope that was clear. Very simple. Now, to get the common boundary between two class intervals, the upper class limits of the class boundaries are added to the lower class limits of the class boundaries and divided by 2. Did you get that? To get the common boundaries, you take the sum of each of them and divide by 2. So that's 20.5, 30.5, and like that, etc. I hope I'm making sense. The upper class boundary of the class is the lower class boundary of the next class. This gives a continuous horizontal axis. Another thing to consider is the class mark or class center. This may be used in finding the mean. For example, okay, like I said another thing to consider is the class mark or class center. Now, this may be used in finding the mean for any class interval. The class center is the average of the upper and lower limits of that particular class interval. Class center of interval 21 to 50 is 21 plus 30 divided by 2, which is 25.5. The class mark for class interval 31 to 40 is 31 plus 40 divided by 2, which is 35.5. That is the class center rather, not the class mark. Okay, so the class mid values, which is the class center, are used in plotting frequency polygon, which is called the OD. So we use the class mid to plot the frequency, the OD table, frequency distribution curve. All right. So in the future, in my next video, I'm going to plot that frequency distribution curve for you to see. And I'd like you to practicalize all that we've talked about here. If you have any question, anything is confusing at this end part, feel free to ask your questions. All right, do have a nice time. I need you all to submit your exercises before the end of this class. All right, so keep staying safe. Bye for now.